Hello and welcome back, guys, to yet another episode of the DevSecOps series. So, in our today's video, we are going to learn about what is infrastructure as code security and configuration management security. So, if you are well aware about the DevOps concept that we have, you might have also known these things wherein you can create your infrastructure, the infrastructure majorly, using certain code files. What do we call them? They are called as infrastructure as code, IaC files. There is a market leader, let's say you can call it as Terraform or AWS Cloud Formation or Azure Resource Template. These kind of tools are heavily used for IaC purpose. So when you write these files, you kind of say that this is an infrastructure that I really wish to create. And then there are certain configuration management tools. Okay, CM is stands for configuration management, and Ansible, Puppet, other kind of tools which you can use to tell the cloud resources that this is how I want my infrastructure that I've created to look like. Okay, one is to create the infrastructure, other one is to tell the infrastructure this is how you should be. Okay, so that's a part of configuration. Imagine creating a house, and then like what is the basic infrastructure that you need columns, you need walls, you need doors, you need uh, reinforced concrete, okay, and you need steel bars or iron bars to create that particular thing. You need slab, so you need to create a net for that particular purpose. But now you need to design a home, so civil engineer would not do that. That would be a part of interior designer. So you want to make this particular wall to look like a pink or purple wall. So that is what customizing this particular infrastructure. So that is called as configuration management. So both of these things are different. So we will see that how to secure whatever you are creating and whatever you are configuring for your application related uh, platforms. Okay, so let's delve into the topic. So what we are going to learn is what is IaC and CM. I guess I told you that particular thing in really short. We can have a long video maybe some time later whenever we will uh, go through in the AWS series later on. But yeah, in short, that is how, as I explained earlier. So what is IaC and configuration management? Then IaC and configuration management, security risk and best practices for both of them. That is what we will see. And then we will check again for a combined workflow for IaC and configuration management security. So that's how our plan for today's security topic is. Okay, DevSecOps topic. So what is IaC and CM? Infrastructure as code. So defining and provisioning infrastructure resources using code. That is the real important stuff that you need to know. This is used to, automate the process of creating same infrastructure you know, uh, in a documented format using code. So that's how you can be sure that whatever infrastructure I'm creating is being repeatedly the same that I want to create, and it can replicate. You can scale it uh, to a lot of same kind of resources if required. So IIC tools are used to create new infrastructure from scratch and manage its entire life cycle. So right from creating to updating to stopping them or to terminating them or to destroying them. That is a particular life cycle that you go through in creation of any infrastructure resources. So that would be all conducted by infrastructure as code tools. So Terraform, AWS Cloud Formation, Azure Resource Templates, and many more. Okay. Then configuration management. So what is it? It deals with the automation, automating the configuration of software, operating system, and applications on existing infrastructure. So as I mentioned, you can paint this particular wall 100 times with different colors. So that is up to you to decide. Okay. So but building this wall is a one time stuff. It is already built, and then only you can paint that particular wall. So that's how you can think about configuration management tools. You can create infrastructure one time and then configure it multiple times as per your requirement. So that is how your application requirements would be changing over time when you develop your application and then serve it to your customers. So that's what you can do with this particular tools. So configuration management tools are used to configure and maintain a desired state of the individual components within the infrastructure. And these tools can be used Ansible, Puppet, Chef, and Salt Stack. So if I talk to a DevOps engineer, he would say that IaC and CM are life-changing tools for them, because they don't have to go through, doing same stuff for 1,000 different servers. They can write one playbook and then it would be applied to all of the infrastructure that, or all of the EC2 instances that they have there, and it would just work like magic. So that's an automation tool that you need to master. Next is infrastructure as code. We would see what are the risks associated with it and what are the different best practices that you can do. So misconfiguration is the major risk that you can have while creating any infrastructure. So imagine, while you are building a house, instead of keeping your column straight, you kind of configured it or made it like this. Okay, so now what would happen? The leaning tower of Pisa would collapse in that case if it is not supported with this particular what we say reinforcements. So misconfigurations like overly permissive IAM policies, unrestricted network rules, public exposures of resources, and then unencrypted storage. These are really dangerous things that you could possibly do. So if you have seen the previous videos regarding secret management, you can see if you somehow by mistake uh, leaked your secrets, it could directly lead to the access of this resource. Now once someone got the access of this resource, if they are not configured to not be deleted, then using the secrets key someone can delete that particular resources. So imagine you have Instagram account and you have certain photos or chats that you do with your private teammates or people or friends, sorry. And now someone got the access of that database which carries the chats that you have. Now imagine what they could do if they got the hold of your chats. Now if they are good, then it's okay. But if they are not, then you are in a serious trouble. Someone could use that data to blackmail you, and then you would be exploited, my brother or sister. Seriously exploited. People lose life, people lose their money, people lose their reputation in certain cases. So that's why it's your job as a security engineer or DevSecOps engineer or a DevOps engineer or an application engineer to keep your entire database, your communication, network communication, and your application secure, so that the people who have uh, an ill intent would not take the advantage of the database of your consumers, and they could have freedom to do whatever they want, not exactly whatever they want, because freedom of expression or speech is never absolute, but still it should be protected. Then excessive permissions can be granted. So with excessive permissions you could access anything of importance, and you can create or modify it in a certain way that could damage the integrity or confidentiality or availability of your resources. Then outdated dependencies and modules can be also configured in your IaC. Okay, and then they could have any kind of vulnerabilities, as we have seen in our previous DAST or IST or Rust tools video, and then they could be attacked in certain way. Then there is a risk of configuration drift, insecurity faults, and hard-coded secrets, as we have already seen this thing. Now, what about configuration drift? Now imagine you built one house with walls like this. Now, by the time someone went without the permission into your house and then tilted both of the walls like this. Okay. Now, in a real possible situation, that would not happen. But just imagine if that would happen with your cloud infrastructure. That is really very possible. So now, if those walls are tilted in slight 1 or 2 degree angle, would you be able to notice that difference? Of course not, until you use any tool. But if that happens, then there is a serious damage that could be caused even by 1 or 2 degrees for your house. So detecting that drift in the configuration or the infrastructure that you have set up is really important. So that's where you can have certain tools deployed in your system which would check the actual state versus the desired state of your infrastructure. So desired state is what you have written in your code files, and the actual state is what is there in the production environment or the cloud environment. So it would check if it is the same that you have written. If it is not, it would show you that your actual infrastructure is slightly different than what you have written in your files. Do you mind checking it and hopefully resolving it, or rolling it back to the actual state, or to the desired state? So that's what is called as configuration drift, and you can see for it. Then insecure defaults, you can have any particular availability zone set as your default, and each time you build your resources, it would be deployed in the same region again and again. Now imagine certain uh, natural disaster occurred in that US East 1A zone. Now what will happen? Okay, your entire uh, data or system would collapse. So that's why defaults, using that particular defaults is not recommended, but having them as an insecure default, because if you are talking about a API token that is used to access certain database, then that would really cause to a leak or confidentiality loss of your application or resources. So that's what about um, the risks that are associated with the um, infrastructure as code files. So I hope you are good with that explanation. If you really have certain difficulty in understanding these things, please reach out to me on my LinkedIn, or comment in the section that is below. So next is the best practices that we can adopt for infrastructure as code. So now, as we have discussed a lot of risks that are associated with it, now we would talk about the solutions that you can adopt. You can use an infrastructure as code scanning tool, okay, to prevent or to highlight certain major uh, mistakes you might have made while configuring your infrastructure. So Checkovi, TFSec, Terrascan, Kix is a framework called as keep your infrastructure as code secure. Then Sneak is a commercial vendor. You can have that Sneak IaC tool deployed to check for misconfigurations and other risks associated with your code. I mean, the infrastructure as code. Then use policy as code for compliance. You can seriously use open policy agents, as it is a part of the uh, what's that, CNCF projects, and it is really helpful to configure a Rego policy, and then scanning your uh, tools or your methods or whatever the procedure you adopt in your organization wide level, and then you can scan against this OPA, open policy agent, I mean open policies, and then these agents would help you to comply with the regulatory bodies that we have discussed earlier. Then Sentinel is for Terraform. Then you use version control for IaC. Okay, as you use version control systems like GitHub, GitLab, or Bitbucket for your application code, you should also uh, push your IaC code in the uh, same version control system, so that you can track how you have modified your infrastructure as per the growing needs of your organization or your application, so to say, or the policies that were implemented, so that you could do an audit of what your organization or your development team goes through. So that is about version control. Then avoid hard coding credentials. I think we have discussed this enough in our previous video. If you do not remember about it, you can check this particular secret management or secret detection and management video, and you would have enough information about this hard coding stuff. Then apply least privilege principle in IAM roles, and you should majorly give deny by default, which comes under zero trust architecture. Okay, so anything someone wants, okay, I want access to this database. So check if you have that role or that permissions. It's not deny it by default. Do not give any access really easy to someone who is asking for it. So that's why apply least privilege principle, and only privileged user should be able to perform certain actions on your resources. So we would mainly see certain practicals of these particular least privileges whenever we will learn about IAM roles and policies in our future videos. Then what is continuously monitoring of your drift detection, defined versus actual infrastructure? As I already mentioned you in the previous slide, that you should be able to detect this particular drift for desired versus actual uh, infrastructure. Okay, desired or defined infrastructure that you have set. And then enforce code reviews and approvals for IaC changes. No one should be able to make changes without any approval. That is of really importance for us. Okay, otherwise then there would be serious consequences if some intern deleted databases. Next is configuration management associated risks. So there could be misconfigured operating systems. Consider operating system or a machine that has all the ports open. Imagine what kind of attack you would be facing in that case. Then hardening baselines. Okay, there are certain uh, benchmarks that you can follow for hardening your infrastructure. Okay, virtual machines or anything that you kind of configure. Then insecure defaults, weak SSH configuration, default passwords, as I already mentioned. Inadequate access control. Okay, now someone could give you access or not. Who is responsible for that particular thing? It is the admin. So admins are usually in charge of providing access to all of these organization members. So they should be really aware about how to configure certain policies, uh, and how to apply these particular access controls across the resources or the accounts that you have for cloud or anything else for that matter. So having these things to be managed by one person is really hard. Making it possible through any configuration management tool becomes easy. So that's why a person in charge should be equipped with the skills of managing these configurations or writing them at least, so that they could create certain policies for access for either resources or for people that are going to consume these resources. Then unpatched systems. So imagine using Windows XP in the age of Windows 11 or 12. So there would be serious consequences of using Windows XP version, because it would have a lot of vulnerabilities that are already there in the market. And then as you are not using the latest systems with the latest security patches, you would be highly you know susceptible to any external threat or attacks. So that's the reason, and you should generally stay updated in the systems wide or operating system configuration, so to say. Then insecure protocols using SSH, HTTP for that matter. For now, any kind of secret communication or any resource critical application. So insecure protocol will lead to disaster. So make sure you configure your policies or your softwares or your infrastructure in such a way that they would deny or redirect all the insecure protocols to a secure one. Okay, using SSL, TLS, whatever it may be. So Then inconsistent environments. So imagine one, uh, imagine Pushpa. One shoulder is like this and one shoulder is like this. This would really, in a real scenario, would lead to a disbalanced posture and a bad health. But I don't know how does that particular person manages in the movies that they show. So inconsistencies would lead to um, some you know threats for environments. So latest one would have less threats as compared to the others that who have which have not been patched with the security patches. So this would lead to inconsistent environment. One would be updated, another would be not. And then if certain things are found, then they could be compromised, or that would affect the performance in of the application. So that would be a general stuff. So if I don't talk about security risks, then there would be performance related issues for the application. So that's why consistent environments gives you full visibility and good monitoring for your applications as well as the hardware infrastructure that they are deployed on. I know sometimes I sound little repetitive, but it's for your good because all of these things revolve around uh, security, so to say. Then let me just fit myself right over here. Okay. Then we have security best practices for configuration management system. So secure inventory and vaults should be used. AWS, I mean, sorry, Ansible Vault, Hashika Vault, AWS Secret Managers for credentials, as I already discussed in the secret management and secret detection and management video. So make sure you really check that particular thing because we have discussed in really great detail about that particular thing. Then CIS benchmarks and hardening. Now there are certain uh, standards that you can follow so that you could really gain the knowledge of creating hardened operating systems or hardened virtual machines or anything like that. So CIS benchmarks would really help you in doing that. We would see what are those in a couple of minutes. But automate compliance with CIS NIST or internal baseline criteria, and you can use certain tools. Okay, CI Ansible hardening roles and Chef Inspect to scan your applications or infrastructure for that configurations. Then immutable infrastructure, prefer redeploying over patching servers. Okay. Now immutability, it means if you have some resources, now you want to make certain updates to that resource. Okay, you want to change it in this way or you want to upgrade anything. Now instead of doing it on the same infrastructure, what you do is you destroy the old infrastructure and then create a new infrastructure with the required configurations. So that is redeploying the infrastructure with newer instances, not just patching the old infrastructure that you have. So this gives you that the surety that whatever it is update that you wanted, it is applied properly and they are with the same dependencies that is required. If not, then patching one server would lead to inconsistencies in the dependency trees or management. So that is the reason that you kind of destroy anything and then redeploy it. Otherwise, it could cause really inconsistent behavior in that meter. So that's why immutability is one stuff. Now remember, we would be discussing these certain topics in a separate series regarding certain keywords that are important for developers as well as security engineers as well as DevOps engineers. So that would be a short series of a long list of certain uh, keywords that you somehow find difficult to understand, or you like if someone is talking about immutable infrastructure patching updates and you don't really know, okay, what is that stuff, I don't know. So to address that thing, we would start that series as well. I haven't yet decided the name, but it would highly be technical jargon series. So yeah, that's upcoming in some weeks, maybe when I'll be more free to do that. Next is patching and updates. So automate security patches in a playbook and recipes, so that you would not be worried about doing it manually. Then logging and auditing, track all the changes to configs and who applied them. Repudiation, another technical jargon, so that we would see in the series. But for now, who applied them? Repudiation, it means if someone did something, you should be able to track who did what in your infrastructure and your entire application, so that you would have a track of whatever the changes are made, either they are done by a certain authorized personnel or are they unauthorized. And then you would know, okay, this is a mistake, and you should audit and find that particular thing out, so that you could remediate or take any action required to resolve that issue. So that is what login and auditing would help us to do. And then role based access control, RBAC, to limit who can run playbook or deployments. uh, so as I think we have already learned about this thing, that you should be applying trust architecture for your entire access controls. So one thing is role based access. Only those with admin roles could perform deletion of this resource. Only those with developers would have the access to commit or merge this particular code base into the main branch. So these are different access that you provide as per the roles assigned to any users. So that would be under identity and access management uh, kind of scenario. So we will see it in certain later videos. So for now, just remember, if you are the prime minister of a country, you can enforce any policy. If you are not, you could be seriously called something that I don't want to say here. So that's it for the configuration management security based practice. Now we will learn about the combined IaC and configuration management security workflow. So let's see code commits. In the code commits, you can check for, I mean, sorry, as I was saying, what are the things we would do in a workflow for configuring security for infrastructure as code and configuration management. So in the code commit phase or the pre-commit hooks, CI/CD pipelines, policy informant can be done. Okay, so this is what we would see. So IaC or configuration management files should be checked into a Git repo. Now, once they are checked in, you could run a secret scan or IaC linting. So linting is again another technical word that we would see sometime later. Okay, linting, it means how you have written it, either it is in good way or not. Okay, considering only the syntax. Okay, not anything other. Misconfiguration is not considered as a part of linting. So run a secret scan and then ISLint for in the pre-commit hooks, and then once it is in the pipeline, scan with the security tools or misconfiguration finding tools for this particular thing. Okay, and then once you find out if there are any inconsistency, you can block insert insecure images or merges, sorry, not images, merges. And then while deployment, secrets are injected in using any vault or secret management service, so that you would not be leaking the secrets. And then post deployment monitoring for drift detection and continuous compliance checks should be enabled for your infrastructure. So that is what you can do for securing your entire workflows. Then comes the infrastructure as code security and configuration management security. So secure infrastructure definitions, and then secure systems or software configuration. This is what you have to remember or say in the interview to the analyst, so that he would get to know, okay, what do you mean by IaC security? So creating secure infrastructure definitions or desired state files is what IaC security. Uh, Configuration management is to create that particular infrastructure as per our requirements, and a secure software configuration should be employed with that particular stuff. So that is was IaC and CM security. Then different tools that are used for both the stuff, IaC and CM. So we would see open source and commercial tools. So Checkovi, TFSec, Terrascan, Kick framework, keep your infrastructure as code secure, and then Ansible Vault for configuration management, Chef Inspect, Puppet, Bolt, Remediate, and SolveSpec SecOps. These are the tools that you can find free to use, and then there are commercial that you can go for Sneak, Bridge Crew, Cloud Custodian, Spectral Ops, and CI SAT, CI Cat Pro, and then HashiCorp Vault for configuration management security. So you should, remember at least one, or you should know at least one or two tools that could be, helpful for creating in secure infrastructure, so to say. So that's all for our today's session. I guess we have covered a lot of topics in our shift left security phase or DevSecOps series, and now here we are with the infrastructure and as code and configuration management security. We have done this. There is one masked stuff. We have done IST, RASP. I think we have not done WoF. We have done secret management. Okay, yeah, done. Then there are certain stuff remaining on my end, so we will see it in our next you know videos. So until then, I would recommend one more thing that you should be looking for. Okay, let me show you one more stuff before we uh finish this thing. Framework. So this is what you can go and check for. I have given this particular link, and in the list that we have, and you can go for queries. Under this queries you would see what are the different stuff you can do for uh, you know creating queries and general info, where it is this thing in the query list. Here you would see a list for all these queries. You can see access control, insecure configuration, network and firewall configurations to be done for these kind of resources that you would be creating. Either it is a cloud formation template, CI/CD, Google Deployment Manager, Docker file, or a Terraform file. You can see what are the security stuff that you can do. Okay, so you can do OSS, open source survey bucket, allows all connection from all principals, access controller, the kind of critical stuff, and you can see the query details of what it says. Okay, severity is critical, and then common weakness is 284, and then a lot of different stuff. Okay, if you write certain policies like that, this is with security vulnerabilities, and this one is without security vulnerabilities. So this is how you can analyze your infrastructure, and you can see the documentation of how to employ Kix framework alongside with your CI/CD and all this stuff, and it would again give you the findings out of it. So that's how we will see it in great details sometime later whenever we will do a hands-on for it. But for now, that's all I think we can see. And okay, if you like the video, please do like, share, and subscribe to the channel, and share it with your friends, and give me a thumbs up if you liked it. And that's all for now. Bye and take care. Keep learning, guys.